You can take a look at these basically, they're called notebooks, and these are the web pages that will allow you to run FLEXvalue directly. So we have two of these web pages that we're going to cover today. The first is linked here, and this is the FLEXvalue calculator itself. And the second is a tool that we've built specifically to allow you to compare FLEXvalue outputs with CET outputs. So for those who are not familiar, the CET, generally we're referring to the California cost effectiveness tool. And we've built a calculator, or we've built a notebook that allows you to simultaneously prepare FLEXvalue inputs and CET inputs, and then parse the outputs after you've done so, and then get a comparison between the results from those scans. There's really a couple options for running FLEXvalue. Option one is this Colab notebook. And for folks, you can go to the chat, and this link should already be pasted in the chat. So if you click on this link, then you'll open up this notebook, and this is where we're going to start focusing our attention when we're getting you up and running. No code experience is necessary to run this. You'll see some code, and it can be a little discombobulating to see code. But if you can just focus on the fact that you actually don't need to write any code, it's not as intimidating. And then there's a user input file and the optional metered load shape file that I talked about a minute ago that you'll need to upload. We'll provide some template examples of these, so you'll have a starting point. Option two, for more advanced users, there's a Python library. It's, again, it's fully open source. You can download the avoided cost and load shape tables, clone the repo, import FLEXvalue, the class, and then use these classes and methods. And there's a full tutorial that Steve will give you a little breeze through where you can actually see everything that's going on under the hood. And for advanced users, this may be your preferred option. And then finally, in the future, we'd really like to see FLEXvalue integrated in a full web interface. I hope users, get some experience running this stuff, and ultimately there's some support from the community in doing something like this. But there's no reason that FLEXvalue can't be made, very user-friendly with a nice website that's devoted to it.
All right, so again, I'm Steve Suffian. I'm gonna walk you through some of the code and also some of the those notebooks that we've been mentioning. One more link I want to put in the chat is a link to all the documentation for FLEXvalue, which also in it has links to these other notebooks that we're talking about, as well as the tutorial. So I just put that in the chat. And here you go. Can everybody see my screen? Yeah.
Looks good, Steve.
Okay, cool. All right, so here's this, here's the read the docs. So read the docs is like a common set of documentation for Python libraries on the internet, and this contains all the information, most of the information that Adam's gone over, including the Colab notebook links and some more detail about the avoided cost data and the different tables. So I'm first just gonna, so this first Colab notebook is that link that we sent you originally, which is how you can run FLEXvalue directly, where you put in your own user inputs and your own metered load shape. The second one is that CET comparison tool. The third one is an exploratory tool to let people be able to plot the deer load shapes that we have available and download either the deer load shapes or the avoided cost data as CSV files. And then this fourth is the tutorial for more advanced users. And so the rest of this documentation just goes through. Oh, also here's the link to the actual SQLite database, which is how FLEXvalue runs the code. But like I said, this notebook allows you to download these components in CSV. And here's all the different components. There's some more information about the user inputs file that Adam went over, and the format, as well as the metered load shape file, and some information about how to run it locally. Okay, so now hopefully everybody try to follow along if you're able to. We hopefully can have everybody be running this at the same time. So if everybody can click this first link, if they haven't already, which will bring you to a page that looks just like this. Called,
and this is the link in the chat, by the way, as well.
And what we're going to do is if you can see on the left here, there's this little play button. And what we're going to do is we're going to just run each of these steps of code. And I'll go over exactly what's happening during each of those steps. But if everybody could just first click this first one, it might come up with the screen, click run anyway. And then also click the second one. Just do that and I'll start talking a little bit because it takes about a minute or two. What's happening in these first two cells is in the first one, it's installing the FLEXvalue package that has all of the code. And the second one is one that takes a bit of time because this is downloading that SQLite file locally into this notebook. So when you run this notebook, it's actually running in your own sort of Google managed space. And so it's not like if you run your load shapes in here that will have access to any of that data or anything. This is actually making a copy in your own sort of Google space. And so because of that, it has to download the full avoided cost information down into the space so that it can use it in the subsequent steps. Another thing that you can see is it's pointing to the year 2020. So the idea of this is that you can easily be able to download the 2020 results. And once 2021 comes out, you'll be just flip from 2020 to 2021, be able to download the newer cost effectiveness, the newer avoided cost data, and be able to easily compare how things may have changed between the years and everything like that. So this seems to have finished running. And so the next thing we're going to do is we're going to hit the same thing on this cell right here. This is just importing some other Python libraries. Then we're going to run this cell right here. And what this is saying is this is essentially providing an example user inputs file so that we can all sort of download this file if you click on this link, and we'll be able to then run it. And this file points to some, well, we'll open it up, but it points to that same SMUD load shape that Adam mentioned. And so you can see how it looks here. It looks very similar to the one that was in the PowerPoint. And so once you have this downloaded, oopsies, run this next cell, and that'll give you a little button here called choose files. And so we're then going to upload that file we just downloaded to our computer into this notebook space. And so example user inputs metered. Okay, and you should see something like this. And I'm just going to pause here in case anybody has any trouble getting to this step. So far, we've just sort of like downloaded the avoided cost data into this notebook and downloaded our user inputs file. All good in the chat, Adam?
Yeah, I'm taking a look here. 1 second. I think so.
Okay, so this next file just shows that we successfully sort of uploaded this into the notebook, and it's just displaying the same user inputs again. And so we're going to do a similar thing for our custom load shape. So you don't have to provide a custom load shape if you're only using these deer ones, but in this example, we're going to pull in the custom load shape as well. And so we also provide an example file that matches with this custom load shape. So you can also download that. And then if you run this one here, click choose files, and you upload the custom load shape file. So now we have both the user inputs file and the custom load shape file in the notebook. Okay, so that was all the prep steps. This is where all the meat and potatoes are. So when you run this is actually, you saw he mentioned this FLEXvalue Run, which is the name of the class in the library. And this is actually doing the calculations using FLEXvalue. It's pointing to a specific database year, like I mentioned, so to make it easy to be able to run it for different years. And it's also passing in the load shape that we uploaded. And here's the results. So this includes all of the input data as well as the TRC, the pack, electric and gas benefits, the GHG benefits, that it broken down for each row. We also have it output where it recalculates the TRC and pack for the combination of all of those into a single sort of output. And then you click this. If you click this cell, it'll download those results onto your computer so you can use them for everything else. And then we also have this final cell, which if you run, it actually takes the results and provides a number of plots to make it easier to interpret what actually happened here. And some of these will look sort of familiar because they'll be similar to the ones in the PowerPoint. Yeah, and if everyone's gotten that far, that is FlexValue.